Plastic pollution is suffocating the planet. And now, a team of Yale researchers may have found a radical new way to turn this crisis into opportunity. Every single year, humanity churns out a staggering 460 million metric tons of plastic, with less than a tenth of that ever seeing a recycling bin. The consequences stretch from the deepest ocean trenches where plastic bags have been discovered to the insides of our very own bodies. With studies detecting nanoplastics in human brains, the message is clear. The challenge of plastic waste is only intensifying, and solutions are desperately needed. Scientists have been in a global race to unlock the mystery of transforming plastic back into something useful, specifically converting the petroleum-based material into energy-rich oils. The frontrunner for this transformation is a technique called pyrolysis, which essentially superheats plastic in an oxygen-free environment, pushing temperatures up to an incredible 900 Celsius. That's about 1,652 Fahrenheit. This process shatters the long polymer chains of plastic, breaking them into chains of hydrocarbons, the basic building blocks of fuels like gasoline and diesel. To make it more relatable, imagine breaking down spaghetti noodles, the polymers, into small bits for easier cooking, the hydrocarbons. Popular Mechanics notes that pyrolysis can typically convert around 60% of plastic waste into bio-oil. Yet, there's a catch. Pyrolysis has developed a reputation for being an energy hog, often demanding expensive chemical catalysts to get the job done. This complexity has made it hard, if not impossible, to scale the process up and make it commercial. Here's where the recent breakthrough becomes a game changer and a point of heated debate. A group of Yale scientists have engineered a novel device that can efficiently transform plastics into fuel without relying on any catalysts. Even more impressively, their innovation extracts 66% of fuel-relevant chemicals from polyethylene, surpassing previous technologies. So what's their secret? The team designed a 3D-printed electrically heated carbon column reactor composed of 3 sections, each with progressively smaller pores. These varying pore sizes help carefully manage the chemical reactions, which is a significant leap in optimization. Tight control of temperature during the process boosts efficiency even further, making this a more promising and scalable pyrolysis solution than ever before. Published in the prestigious journal Nature Chemical Engineering, the Yale team's results show that their reactor can selectively and efficiently upcycle plastics into valuable chemical products, all without the traditional pitfalls of broad, low-quality output and high energy costs. To put their new system through its paces, they also built a carbon felt version, less streamlined, but still extracting a solid 56% yield. That's ahead of most legacy pyrolysis methods. To quote Shu Hu, Yale's assistant professor of chemical and environmental engineering, "These results are very promising and show a great potential for putting this system into real-world applications and offering a practical strategy for converting plastic waste into valuable materials. Yet, not everyone is sold on pyrolysis as the answer to our growing mountain of plastic trash, and this is the part most people miss." Critics argue that technologies like pyrolysis are just another smoke and mirrors act by the plastics industry, more greenwashing than genuine progress. Some investigative reports allege that the entire pyrolysis promise is based on questionable math and marketing, painting commercial-scale pyrolysis as little more than fiction. Isn't this just another chapter in the long saga of big promises around plastics recycling? So, what's the verdict? Even with Yale's exciting breakthrough, some experts insist the only real solution is to reduce production of plastics in the first place. Does this bold new invention signal hope for a cleaner future, or is it simply prolonging our addiction to single-use convenience? Here's the controversy. Can revolutionary technologies ever truly beat the problem if we don't change our consumption habits? Or is science finally catching up with environmental reality? Let us know your thoughts. Do you believe in pyrolysis, or do you think it's just another clever distraction from the real issue? Jump into the comments and join the debate.